Mrs. Hauser here. We're going to talk about Unit 1, Lesson 1, slope. So what did you need to know from this lesson? You need to know how to find the slope between 2 points, how to find the slope given the graph of a line, how to find another point on a line given a point and a slope, and how slopes affect parallel and perpendicular lines. So let's get right to it. I've given you 2 points here and we have to find the slope between them. There's 2 approaches to this. The first is to use the slope formula, so let's go ahead and do that. Slope formula is y2 minus y1 over x2 minus x1. A common mistake here is to do x2 minus x1 over y2 minus y1. So a way to remember how to do this correctly is to always make sure you're doing your rise over your run. Rise is vertical and run is horizontal, and we know that our vertical axis is our y-axis and our horizontal axis is our x-axis. So if I'm going to plug in these points, I like to label them. So my first point gets 1s and my second point gets 2s. And then this makes it very easy to substitute. So let's go ahead and do that. We have to do y2, which is 6, minus y1, which is negative 3, over x2, which is negative 2, minus x1, which is 4. I know that when I subtract a negative, that's the same as adding. So I'm going to get 9 over negative 6, and I can reduce that. 9 and 6 are both divisible by 3, so I get 3 and 2, and I'm just going to pull that negative out in front. So there's my slope. I can also approach this problem by graphing these points. So 4, negative 3, and negative 2, 6 are graphed. Then I'll draw the line between them. And I would then draw in my rise and my run. So my rise is vertical and my run is horizontal. And then what I'll do is I'll count these boxes. I count the boxes and not the lines so that I don't make a mistake. So I count 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I count 1, 2, 3, 4, 5, 6. I know that my rise is going down, so that would be negative, and that my run is going to the right, so that stays positive. Then what I would do is look at rise over run, and I would get negative 9 over 6. Again, I can reduce these because 9 and 6 are both divisible by 3, and I get negative 3 over 2. This slope certainly matches this one, so I know I've done it correctly. There are a couple of things that I just want to note. We have 2 special slopes that we call undefined and 0. When I use the slope formula, an undefined slope would look something like 4 over 0, which I can't divide out, so I get an undefined answer. It doesn't matter what number is in the numerator, anything would be undefined with a denominator of 0. And when I graph it, it would look something like this. My 0 slope would look something like 0 over 4, which when it is reduced gives me 0, and when I graph it, it would look like this. Be careful when you're reducing these. Make sure that an undefined slope has a 0 in a denominator and a 0 slope has a 0 in a numerator. All right, so let's find the slope given a graph. My line disappeared, so let's put it back. Okay, I've got my line back there. So let's go ahead and find 2 points on the line. What I'm going to do is look for two, what we call integral coordinates. And what that means is that I have integers for each coordinate of the graph. Okay, so what I'm looking for is two integral coordinates. I see one here. I also see one here. So that means it goes cleanly through. So I'm going to draw in my rise and my run. I get -2 as my rise and 3 as my run. I know that I can find slope by doing rise over run, and I would get -2 over 3. Just going to pull that out over there. I could also have chosen to pull the coordinates off of this graph and said that I'm at -2, 4, and 1, 2, and substituted those into the slope formula, but I think that using your rise and your run is an easier method in this particular instance. Let's find another point on a line. So I'm going to start by graphing my point 8, -1, and then I'm going to use my slope that's given to me, which is -4, 3. So I'm going to go down 4 and over 3, and I end up off of my graph. So what do I do if this happens? I actually want to take 4 over -3. These are equivalent, so then I'll go up 4 and to the left 3. And I'll do it again. And then I'll fall off my graph if I try to do it once more. So let's look at what we have to find. They want me to find a y coordinate for the first point and an x coordinate for the second point. So I know that my x coordinate here is equal to 2. So I'm going to look at that. If my x coordinate is equal to 2, I like to take my highlighter and look at where that is. So at x equals 2, I put a little highlighted mark. And I know that every value all the way down this line, every point has an x value of 2. So I'm looking for the one that actually is on my line. Well, in this case, that point is located here. So I just need to find the coordinates of that point. The coordinates of that point are 2, 7. So I have a y that's equal to 7. I'm going to use this same method to find the x coordinate of x3. But now I know that my y is equal to 3. So I'm going to highlight a y value of 3. And I know that every point along this line has a y value of 3. So I just need to find the one that fits my slope right here. That point is located at 5, 3. So my x value is 5. So I have my two answers, y equals 7 and x equals 5. So now we're going to talk a little bit about parallel and perpendicular slopes. Parallel lines have the same slope. So if I was given a slope that was 4 over 7, the parallel line would have a slope of 4/7. Perpendicular lines have what we call opposite. Sometimes we call it negative reciprocal slopes. Remember that reciprocal means if I have a fraction that's x over y, it would go to y over x. So in this case, if I have a slope of 4/7, the perpendicular line would have a slope of 7/4, and it would be negated, so it would be negative 7/4. Likewise, if I have a slope of -2, that's actually -2/1, my perpendicular line would have a slope of 1/-2, and I would negate it, so it would be positive 1/2. I want to talk about one more thing. If we look at the number 0, the negative reciprocal of 0 is, I can put 0/1, 1/-0, I would negate it, and this is actually now undefined. So 0 and undefined are perpendicular, which makes sense because if I draw a picture, they are perpendicular. So let's look at some examples of applying this. If I had a line here, I would again find two integral coordinates, which you now know what that means. Here's one, and here's another one. My slope would be 3/2. And if I were to take a point, let's say 2, 2. And I wanted to plot a parallel line, I would use that same slope. I'd go up 3 and over 2, up 3 and over 2, down 3 and over 2, down 3 and over 2, and I just connect those points. Now you might ask me where I got this point from, 2, 2. Where did it come from? It came from, I just wanted to use one specific point that I could graph a line off of. Normally you'll be given a point that you'll work with, so you'll just use that one point as your starting point and use that slope over and over and over again. Okay? So now let's talk about the perpendicular one, and I'm actually going to go ahead and graph that same 2, 2 so we can work with that point. So I'm going to, again, find integral coordinates. It's going to be really easy this time because it's the same graph. And I'm going to find my slope. It's 3/2. So this m is equal to 3/2. My perpendicular slope, this is our symbol for perpendicular, and this is our symbol for parallel, is going to be the negative or opposite reciprocal of that. So my slope here would be the reciprocal, and I would negate it. So now, if I use that point 2, 2, I'm going to go down 2 and to the right 3, and I'll keep doing that. Or up 2 and to the left 3. And when I graph this line, you can see that it's perpendicular. Sometimes I'll ask you just for one other point. As long as you put a point that uses the appropriate slope, that's fine. It doesn't matter which point it is. It just has to fit onto that graph. Sometimes you'll be asked to actually graph the line like we did here. So you always want to make sure that you find your slope of your original line and then find the appropriate slope to work with. Remember that if you have a line that has an undefined slope, the perpendicular slope to that, and I can put any number, 4/0. If I take that negative reciprocal, I get 0/4, and I negate it. I get -0. There is no -0. It's just 0. So we would be done. So make sure you're careful with looking at those slopes and finding those negative reciprocals. Okay, that's what we talked about so far in the first lesson of Unit 1. If you have any questions, please make sure you come see me for extra help, but I hope that this helped prepare you.